Hi everyone, and welcome to our second application on quadratic functions and finding a maximum or minimum. So this one's got a little bit different setup than that first one. So the first one, which should erase now, they gave us the functions, which was real nice of them. Here we have to find it and then use it. All right, so on this it says a luxury cruise charges $4,000 per person plus a $200 fee for each unsold ticket. The cruise holds 50 passengers. Let X represent the number of unsold tickets. Okay, so they're telling us X represents the number of unsold tickets, so that's interesting. And now let's break down how they want us to continue. So on number one, find an expression for the total revenue received for the cruise. Okay, so in this problem, they don't give us the revenue function, unlike this previous one, which is real nice of them. Here we have to find it, which means we have to kind of remember that revenue is equal to a price times a quantity. Okay, and so we need to figure out how to set up a function with our x. Well, based on this information, let's go ahead and set up the scenario of them being perfect. So if they sold all tickets, our revenue, so I'm not going to do R of X yet, let's just do R, would equal the price of $4,000 per person. Here, there wouldn't need to be the $200 fee for each unsold ticket, so we don't have to worry about that. And it says it does hold 50 passengers, so that means all 50 would have been sold. So there we go. And so from there, we could multiply it. It would be 20 with 1, 2, 3, 4 zeros. Okay, so $200,000. Okay, so I just wanted to see that because this $200 fee thing's a little strange. All right, let's see if they let's do one with one unsold ticket. Okay, so one unsold ticket, which would be revenue is equal to. Okay, so if one ticket goes unsold, that means it would have been 49 total here instead of 50. And then instead of 4,000, though, there would have been a plus a $200 fee. So instead of 4,000, it would have been 4,200. Okay, and so from there, that one I don't know right away. I need my calculator for that. Okay, so 4200 times 49 gives us 205,800. So notice it's a higher price. So it looks like this little extra fee gives the cruise a little bit more money. So what we want to figure out is what is the best for them to sell. Okay, so clearly they don't want to sell all the tickets. They want to go under. Well, based on this pattern here, so notice this from here to here was plus 200. So that was the $200 fee. From here to here, that was the one ticket getting sold, so minus 1. Well, these little constants that I'm putting here, that goes with the unsold tickets. That means all I have to do is attach X to my original 4,000, or my original blue equation with the plus 200 and the minus 1. So what I mean by that is let's go ahead and combine all that information and say our revenue function would be 4,000 plus 200x times our 50 minus x. Okay, so remember x is the number of unsold tickets. So this means when to check, when x equals 0, notice it would be 4,000 plus 0 times 50 minus 0. So that is that top equation. When x equals 1, if I plugged 1 into this, it would be 4,000 plus 200, which is the green so far. 50 minus 1 is 49. It matches my green. Okay, so this equation was found by just trying to figure out the pattern to it. Okay, and then now that I have this function, now's where I'm going to go to my graphing calculator. So I'm on Desmos and graphing calculator, and I'm going to type that in. Okay, so it's 4,000 plus 200x times 50 minus x. Oops. And there we go. Okay, so there it is. And then, well, I don't see anything, so that means I probably need to zoom out. Oh, there we go. Look at that steepness in it. Okay, so I need to adjust my axis. Okay, so x, I mean, the biggest x could be is 50. Smallest it could be is 0, because that x is the number of unsold tickets, so it's somewhere between 0 and 50. And then our y-axis, well, we already saw with our kind of scratch work, it was near 200,000 something. So how about we go 0 and 250,000. I think that will make it fit. Looks like it. Okay, so it looks like that, and I can even zoom out a little to see the whole parabola. Okay, so there is our graph. Now, at this point, I don't think I want to just sketch it. I mean, we could sketch it. We could do this and re-sketch it ourselves. I just want to point out the main things. It looks like 15 is going to be important to us. Okay, so let's look at using this graph. I'm going to kind of bring it back and forth each time. Okay, so it goes away. There we go. To help us figure out what's going on. Okay, so this graph is in the picture, but let's find the number of unsold seats that will produce the maximum revenue. Okay, our number of unsold seats is the x-coordinate of this vertex, 15. So 15 unsold seats. So let me at least write our vertex was 15, comma, and then 245,000. Okay, so that's our vertex. The seats is x. The unsold seats was x. So the number of unsold seats that produce the maximum revenue is x equals 15. So it's the x-coordinate that they want for number 3. The maximum revenue is the y-coordinate. Max revenue is the $245,000. So that's it. Okay, so the main thing is that equation, I think. And all I did was just, again, kind of tried to figure out a pattern. And notice I'm just thinking, let me highlight these in pink one more time. I just attached x to these little addition and subtractions to my original 4,050. So that's all those were. Just attached x to those constants there. Okay, so that's how we can find those in these problems. Okay, it also could, I would say, always start with the best case scenario, or at least what we think would be the best case scenario, all tickets sold, and adjust from there to find a pattern. Okay, so that's the two ways to kind of start getting that equation going. Okay, anyway, so we found everything, though. Once we had the equation, it was just this graph. Remember, the maximum or minimum is the y-coordinate of the vertex. Sometimes they want that x information, too. Okay, so that's it for quadratics. Thanks for watching. If you do have any questions, please let me know. Otherwise, I'll see you again soon.